Next up is Curtis Lindquist, who appears to have injured himself getting here. Yeah, ski. Curtis is Chief Executive of NetNod, Swedish Internet Exchange.
Thanks.
And he's very active in the IETF, so every so often Curtis comes along, gives us an IETF update. So I'll hand you over to Curtis.
Am I unmuted? No, yeah. Hi everyone. I'm not here as NetNod today. I'm actually here for that I go to the IETF meetings quite frequently, not to say all of them. A long time ago I did a first presentation, and then I also gave a bit of an update of what the IETF is and how the structure is. So if you feel a bit unfamiliar with the IETF, I recommend you go back and look at those slides. The IETF, I think in total has something like 170 working groups, and I decided to pick out a few of them that I thought that are currently quite active and might be of some operational relevance. And I'll tell you a bit about what they do, and I actually forgot to include a link on how to join the mailing list, but anyway, I can show that to you afterwards if you want to. So a very quick run, and I'm also a member of the Internet Architecture Board, and therefore I have some insight in what some of these things that are happening. I also think that Matt in the afternoon will talk about some of the more interesting stuff, maybe from an operational point of view. The first working group I was going to talk to you about is called Sixman. The IETF standardized IPv6, as you know, and IPv4 for that matter. The original working group that standardized the IPv6 base specifications concluded that was shut down. That what happens when a working group reaches the end of charter. Instead, a new working group was created called Sixman. Sixman is basically tasked with updating standards where errors are found or unclarities are found, and also hopefully to advance the IPv6 base-related specifications throughout the standardization maturity levels that the IETF has. Not all of this might be of operational interest. A lot of this is discussions of how to interpret certain bits on the wire, but there are every now and then discussions, especially on the mailing list, that have some operational relevance and that might be interesting. One of the things that have been discussed, and my guess is that we'll see a lot more of, is this requirement for the /64 for every link, so that even on the point-to-point links, you currently have to use a /64 v6 address space. I know that there will be some discussions of actually changing that, or at least bringing a proposal to this mailing list for changing this, and also looking at some of the address architecture requirements in IPv6. If those discussions ever resurface, this will be the mailing list where you'll see this discussed, and that might be worth looking out for. There is another working group called, there's two working groups called NTP and TikTok. The NTP working group, which are about to conclude, have worked on standardizing the NTP version 4 and some of the related standards around NTP version 4 for author key and some of the, some other issues around NTP version 4. That is basically documenting what the world looks like. Every now and then the IETF takes one of the standards and go back and realize that BGP being one of the prime examples is that the standard says something, in reality looks quite differently, so the IETF decides to go and document reality, which of course is always a good thing. The other working group though that's called TikTok is the NTP version 4 comes with quite a lot of drawbacks, and it's quite limited in what it can do when it comes to time distributions over IP networks or over packet networks. As you might know, the IEEE has also worked on a standard called 1588. The 1588 is basically, and people might disagree with me here, but it's basically time transport over Ethernet. And now that the world's telcos have decided to embrace Ethernet and create this carrier-grade Ethernet, whatever it's called, they also believe that they need to distribute time, or actually synchronization information, frequency, over these networks, and that's basically what 1588 does. 1588, however, needs to, in order for it to work, it will need to have a hardware support, what's called on-path support, for every link jump you do. The idea behind the 1588 requirements, and also why the IETF is looking at this, is that you might need better accuracy or higher frequency distribution over packet networks to, for example, cell towers. As a lot of the new cell towers and base stations that are being sold actually only come with an Ethernet interface, and they then need to get this synchronization information in order to steer the radio part towards the mobile networks. However, there is also work in the IETF, especially maybe from the IP side, where having higher resolution of time would be interesting in cryptographic use cases, but also in the people who do, let me get this right now, meteorology, not the weather, but the people who look at metering time, for example. A lot of that stuff is now being done over IP, and they want to have a lot higher accuracy than we can ever do. Problem here that happened was that this working group is completely invaded by carriers or PTTs and people who had a lot of vested interest in the 1588 standard. And they seem to believe, if you ask me, that the entire world is a single LAN, and therefore 1588 will work fine. It might not. As you know, there's actually most of the long-haul links are actually not running on Ethernet, and therefore this standard is quite useless. It has a mode where you can run in a packet network, but then basically the resolution sucks. So there's a big discussion in TikTok working group is chartered with two things. One is to develop a 1588 profile for IP packets over 1588 supported hardware. You know, there's something we think about. But also to look at options for building a new NTP-like protocol. And if that will be NTP version 5 or a completely new protocol, we don't know yet. I mean, that part of, there's very few people in that working group who actually want to work on that. So if you think that this is important, come and see me afterwards, or even better, join the working group and say that we're not running only Ethernet. We have other uses for this and other needs for this. So getting some more provider input there would actually be quite good. There's lots of people working on cell towers who are active there, who have their own requirements, which are actually not very advanced, by the way. Softwire is a working group that works on, I think there's some text missing here, anyway, that works on specifications for discovery, encapsulation, and control of V6 traversal over V4 domain. So this is basically some automatic tunneling, or semi-automated tunneling, I guess, endpoint discovery and establishment of these tunnels. They were not tasked, if they didn't have to come up with a new encapsulation protocol, so they didn't. They picked L2TP version 2. And I think that there is, although it's not in the charter, there is an ambition to also do this for LTTP version 3. The problem was there's only one vendor who had the code for that. They work on two models, hub and spoke and mesh networks for this tunnel establishment. They also, I was going to say they're moving quite fast, but maybe not. But nothing in the IETF moves very fast. But they have gone quite far. They have picked encapsulation methods, and they are working on this discovery mechanism. So that might be worth interest. It might be worth following as well. Although I think that they partly have been a bit overtaken by events. The other one is a new working group, SAVI, that came from a requirement from a particular country, actually. But the idea here is that very few people today do source address validation or BCP 38 style filtering of source addresses, and so we have all this malicious code sending out spoofed addresses. And the idea was to create some sort of better automated mechanisms where we can have source address validation done very, very far out in the edge. Rather than doing it in the core as we do with BCP 38 style mechanisms or RPF or URPF. The idea here was that you will enable the LAN or some sort of layer 2 device in the text, in the original documents they talk about LAN switches. It doesn't have to be LAN switches, but that was the idea that was taken. Where you have either layer 2 devices or layer 3 aware switches, so it's something that can understand what's happening higher up in the packet format, so it must be a bit more intelligent. Actually look at messaging sent to the end nodes, and they can then auto-configure the address validation somehow. So basically this is, you will snoop DHCP requests or something similar. They do this for V4 and V6, by the way, so it can also be RA or whatever. Look at this packet messaging being sent and configure the end devices to do, or the first hop devices to do this filtering. The original requirement for this, I don't think this is necessarily a bad idea, was a bit misguided, was actually for a particular country that wanted to use this for law enforcement, which you might have different, it was actually China. And you can have different views on whether that was a valid point or not, but the problem they wanted to solve was spoofed addresses. And once we managed to clear that out, then work started moving a bit easier. They're working on looking at the solution space. There's a draft out that describes the variant solution space for doing this. They're also only focusing on doing this intra-domain. So it's only inside a provider's network. There were some original ideas that you could somehow tag routes as having been filtered or having been cleaned in this way, so you could create some sort of web of trust between providers. But as you know, a web of trust on an internet scale just doesn't work, or at least no one managed to make it work so far. So that was scrapped, and instead we're only focusing on doing this in the interdomain space so that you as a provider can deploy this at the edge, but you can't make any assumptions about the rest of the internet. So the problem with BCP38 that it only helps you if the rest of the world deploy it, it doesn't help you if you deploy it, still remains with this solution. But it might make these kind of solutions a lot easier to deploy in a DSL or FTTX environment, which is the people are looking at. Multi-homing, I just bunched all of this together in one slide. There is still a lot of efforts going on looking at how to make a scaling routable routing system. Shim6, which I think I talked about last time I was here, which is quite a while ago, has done this base specification. I'm not going to talk very much about what it is. The base specification has been with the ISG for approval as standards RFCs for quite a while, mostly waiting for the authors to clean up comments from the ISG. There is the IETF who writes the standards, might be the most well-known organization, but there is a sister organization called the Internet Research Task Force, the IRTF, that have a number of research groups. The RRG is tasked with this called the Routing Research Group. They're looking at different ways of doing routing. They are also looking at building a scalable interdomain routing system. And what the components of doing that is and what the challenges are, they have a number of proposals, they have a number of architectural issues on the table. They haven't actually concluded on one way or the other, but one of the ideas out of the RRG is something called Lisp. That's basically being pushed by a group of people at Cisco. There are a few implementations of Lisp. Those are either written by Cisco or funded by Cisco, so this is a pure Cisco effort. That doesn't necessarily mean I think it's a Cisco corporate policy. It just happens that the people who worked on this worked at Cisco and the funding came from there. But I don't see any other support for this at the moment. But they have 2 meetings ago, last summer in Dublin, there was what's called a BOF, the Birds of a Feather session, which is the stage for creating a working group. But there were quite a lot of questions raised about, and then they applied for experimental status, which means that you can publish an RFC, but it doesn't carry any weight. It's just a description of an experiment. And that's what they wanted to do. That BOF didn't go down very well, more because then they actually looked for in Dublin they actually looked for a standards document. Now they're looking for experimental status. In Dublin, there were quite a few questions raised about the architectural decisions in this work. There was also a lot of questions being raised on whether this could be made to work at a larger scale. And people pointed out it had questions. It wasn't necessarily issues, but people had a lot of questions on this work. There's another BOF coming up in San Francisco in a month. I don't know if that BOF will be, none of these BOFs I'm talking about. So in IETF, people can apply for a BOF, and I don't think that the ISG has yet made a list of approved BOFs known. So I don't know if this BOF will actually happen. I forgot to check that before going up here. But it's been discussed anyway. That might be worth following, but again, now they're looking for experimental status, which basically doesn't carry any weight if they even get a working group. But there's a lot of work. The RRG group is having quite a lively discussion on scalable routing system behavior. Operational security, they have been a bit of a dormant group. I think they're coming back to life. And they have published a few documents or drafts regarding operational security requirements. There's currently been some discussions around the document or updating the document for blackholing DDoS attacks. And the latest addition is to expand on RFC 3882 to also support blackholing based on source addresses rather than just based on destination addresses that RFC 3882 describes. CIDR has also been around for a while. They have been working on it sort of stands for Secure Interdomain Routing, which is to add to interdomain routing, basically to BGP, some sort of validation of authenticity and of the announcements and the resources. And they have worked quite a bit on the resources, on the certificates of the resources. And I think there is currently, even on that side, there's 2 implementations. One I think was funded by APNIC and one been done by ISC. Maybe I can't remember. Keith works for ISC, but Keith isn't paying attention. Keith, didn't ISC write one of the CIDR resource implementations, right? And APNIC wrote the other one.
Yeah.
Right.
Mostly with the RIRs.
Okay.
Currently trying to secure some.
What Keith is saying, I think, yeah, Keith is saying that there's been mostly work done by the RIRs, ARIN, and I think it's actually ARIN and APNIC, but people from ISC were involved in writing some of this stuff. But I think that ARIN also dropped the funding on some of these projects, and APNIC concluded or whatever it was. So there's 2 implementations written in 2 different programming languages. I think it's Perl and Python, if I remember this correctly. The thing that's remaining in CIDR, and it's only now starting to be discussed, is how do we actually use these certificates? How do we get them into the routing system? How do we get them into the routers to validate this? And how do I validate an announcement on the fly? Where do I pull the data from and so on? Which is actually the hard part. So not to say that this was easy, by the way. But they are limited to the inter-domain router verification and not as a general general concept. Behave is the working group that has, I can't even remember what the acronym stands for anymore, works on NAT and NAT traversal for IPv4 traditionally. It has done all these protocols for how you interact with NATs and this. I think this is what Matt might talk a bit more about in the afternoon, so I won't say very much, but there is also a work on these carrier-grade NATs, and the NAT64 mechanisms are for doing v4, v6 translation, basically NAT PT updates. And that will have quite a lot of work, impact probably on IPv6 deployment, but I'll leave Matt to talk more about this in the afternoon. Last, what has been proposed for the next IETF, again, I don't know if this will be approved, I'm pretty sure it will be approved. It's called NAT66, which is basically IPv6 to IPv6 address NAT. Now, a few of you might remember that one of the unique selling points of IPv6 is that we restore end-to-end, the end-to-end model and end-to-end communication without having NATs in between. There have been quite a few people pushing for, especially in the enterprise environment, pushing for something like IPv6 NAT, basically to do topology hiding and to ease at renumbering. And there are a few things. There's always the risk that the same thing here will happen as they did for IPv4. That we sat on our high horse and said this is a really stupid thing to do, so people go ahead and went away and did it anyway, and did it in a pretty poor way. One thing with NAT6, what you couldn't do in IPv6 is that you will do one-to-one NAT. It won't be the address sharing NAT of IPv4. It could be a one-to-one NAT in IPv6, which actually make the transport protocol impacts a bit less or easier to deal with. I have no idea if this will actually be approved as a working group. My guess is as good as yours. The people seem pretty split about this. Some people think allowing this to be a really stupid thing. Other people think that it's better that we do it and do it right than let the market do it, because the market isn't always the most architecturally well thinking group. But this would be just for enterprise needs and basically around topology hiding and renumbering. They would certainly love operational input. There's a special NAT66 mailing list, and I'm sure that will pick up the speed as we get closer to the IETF. There is a good document by Dave Taylor who analyzes quite some of the differences why and making a NAT for IPv6 could be made better than for IPv4. Whether that's true or not, of course, depends on the actual outcome of the working group. That was my last slide. If you do want to subscribe to any of these discussions, if you go to www.itf.org, there's a link that says working groups, and then you can just, I know it's sorted by area, but you can just do search on that page and you'll find each of these working groups and instruction of how to subscribe. Any questions? I'm almost on time. There's one question by Matt.
Matt Ford, ISOC. It's not really a question, it's more of it's a question to the room, more of an observation on your presentation. The NAT66 stuff and IPv6 for NAT is, one of the questions I have to some of the people driving that work in the IETF is, what's the customer for this? Show me somebody that really thinks they need this. I don't just want to hear vendors pushing, yet another technology solution for a problem that doesn't exist. So if you think that in an IPv6 world, NAT would still be useful for topology hiding or for purposes of provider-independent addressing, then it would be great to hear you speak up. Or likewise, if you think surely we were moving to IPv6 to get rid of NAT and this is all horseshit, it would also be good to hear that opinion.
Yeah, I mean, it might be worth adding a bit. I mean, the people driving this comes from, as Matt, I think, alluded to, a lot from the vendor space, claiming that there is enterprise demand for this. Unfortunately, the only group that's less represented at IETF than the operators is the enterprise. They're all channeled through their vendors, and I'm sure they're speaking of the customer's best interest. But it would be good to get some real use cases in there, get some real feedback. So, I mean, if you as operators have input from your customers on how they would like to see this deployed, a lot of that would, in general, when it comes to IPv6, getting any form of enterprise feedback would be good on any topic, actually. But especially on this one, it might be good idea to get there. Personally, I think this is a complete waste of time, but that's just me. That wasn't why I was here. That was not with my IB hat on. That was my highly personal view. All right.
Any other questions? Excuse me. Any other questions for Curtis? Okay, thank you, Curtis.
Thank you.